Now, to start with, I have to determine which one of these three atoms is going to want the electrons the most, which one wants the electrons the least. To do that, I look at the electronegativities. Oxygen has more electronegativity than carbon. So oxygen is going to be taking a slightly negative charge. Because of that, if this is sitting in a liquid or in a solid, all the molecules around it now have positive and negative charges. And so I've thrown it in this environment that has positive and negative charges. These positive charges all get attracted to the negative end. The negative charges all want to be attracted to the positive middle. And so now if I look at this as a whole, there's going to be two ends. There's going to be a positive end, a negative middle, and another positive end. There's two ends here. So that if there is some molecule sitting over here that's positive and negative, this positive knows it wants to be attracted to the middle. But the negative cannot decide if it wants to go to the right or to the left. Because as far as the negative is concerned, and let's face it, like that, it's equal. The negative will be torn between going to the right and going to the left. That's for a symmetric molecule. What about one that is not symmetric? Like PF3. Okay, now I look at this, I look at the electronegativities. Fluorine's got the highest, so fluorine is going to become negative. Phosphorus is going to become positive. All the negative charges now, they'll come over here, they'll be repelled and attracted over to the positive charge. Throw the last guy over there. And the positives now will get repelled by the positive on top, attracted to the negatives on the bottom. And now when I look at this molecule, I'll notice something. This molecule lines it up so that there are always positives on one side and negative on another side, so that if there's another molecule sitting in this solution, it has a perfect idea of where it wants to go. The positives have to get attracted to the negative side. The negatives have to get attracted to the positive side. This means that when you have an asymmetric molecule based on the shape, that molecule is able to line up all the dipoles and make them stronger. And we're going to call this dipole-dipole force. And now I've got my dipole. Now if there's a bunch of these sitting around, let's do 6 of them. That's enough. Now they're going to arrange themselves so that the positive ends want to be attracted to the other negative ends. So there, now that positive end is attracted to this negative end. Now that positive end gets attracted to that negative end. And now that positive end gets attracted to that negative end. And I've got this positive end getting attracted to this negative end. So this is another form of intermolecular forces.